it's a fascinating application. It's a vertical one, and that's what makes it also somehow interesting, because we all know that fiber optic sensors are being put into vertical applications, but as I said earlier, the coupling, the strain coupling, bears some challenges for that, and we see how that goes. The setting was a saline production, salt cavern well, and the fiber optic sensing cables were deployed into the cemented casing. And here's my thanks to my co-authors from ESK, who managed and were responsible for the entire installation on site. And this is the core challenge. We need that reliable coupling between the structure, in this case the casing of our well, and the fiber. And since accessibility is not so easy, we cannot just stand there and glue it or strap it around the case. Yeah, we need to see how that works. Temperature compensation is necessary because there are temperature gradients that are not to be neglected. Sometimes in surface installations you say, well, strain is strong anyway, and we do not have so many temperature fluctuations, we can neglect that. Not here. Temperature compensation, temperature measurement is of the essence. So the solution to that was to go into that 550 meters borehole, and while lowering the segments of the piping, the pair of fiber optic sensing cables, strain and temperature cable, were attached to each segment, 11 meter long each segment, and fixed to the centralizers that were especially equipped with a clamping facility on every centralizer element. So by that we got a fixation, a positioning, and a protection when lowering the pipes into the hole. And of course, something that had to be done as preparation work to that was that both the cables had already to be interconnected at the lower end, because the lower end wouldn't have been accessible afterwards. So this was done by a splice, by a very rigid, also pressure-proof protection sleeve, fully sealed hermetically, and by that fixed to the low centralizer. And well, that's what you see in the photograph. That's the return point, and the splicing sleeve is protected in this part of the centralizer. And it worked well. It was a one-night installation, and the 550 meters of cable were lowered with the piping into the well. We did OTDR measurements, like fiber optic integrity measurements, to see if everything was going smoothly, or if we had any kinks or torsion, which would have immediately, of course, killed the fiber optic sensing cable, which did not happen. So I think it was a consensus to consider that already as a big success, to really bring it down. So next day the cementation was done, cement was poured. We monitored that over a few days, and seeing the exothermic curing of the concrete, you see that that in the installation we have a temperature baseline, which is the blue one, which is more or less in the range of ground temperature, and then with the cementation the temperature goes up a few degrees, which is normal because it's an exothermal reaction. And then after a few months of repetitive monitoring, we go there every 3 months more or less, we see that the temperature goes more or less to the geophysical temperature reference that everybody would expect. That is the strain reading. Now, one word on that, because we did the two things that I have discussed earlier. We used the installation measurement as a baseline. So all the strain levels or all the strain values are relative to the initial strain condition after installation. And we did the temperature compensation with the readings that I showed earlier, the same manner as we have seen in the explanation in previous slides. And it's interesting to see that strain is occurring during cementation. We have that interesting strain pattern here. We're still discussing about the interpretation of that, but we already see that the pattern represents the spacing of the settling, so the spacing of the centralism of this fixation point. So that all makes sense. We have a larger strain event right in the middle of the installation, so halfway down it, which also makes sense because there's a known discontinuity in the piping, so that all is well. Now 1 year has passed, and we will continue that for for at least 2 more years, and we're looking forward to see what actually happens there when production cycles change, when possibly geotechnical events might occur. That will be interesting to see. So hopefully we can be able to keep you posted here what comes out of this installation. This has been my talk. Again, thank you very much for being on.